All right, listen up. Please stop me as soon as you have a question. Just shout out and say, hey, stop. Can you explain that? Here's how I want you to do these. This goes for everybody. This is not a suggestion. I want you to factor first. So like this top one, you can pull out a GCF X. Don't drop those. That's another just reminder. Leave the GCF. And I'm going to write this out on the side. Once you GCF the X, you can factor that to X plus 9 times X minus 3. And then factor the denominator to X plus 4 times X minus 3. Okay?
Hold on.
I'm not going to hold on.
No, I have a question. It's the same.
Well, she's not asking me. Okay, after you've done this, this is factored form. It's useful in the process. I want you to write it in simplified form as well. I will be, it doesn't say this specifically, but I'll be looking for it on your paper for full credit. So what is the simplified version of the function? Well, the x minus 3's cancel, so it becomes x times x plus 9 over x plus 4. That's the simplified or the working function, okay? You can use this for things like the y-intercept. You can use it for the y-coordinate of any holes. This is just the simplified, you can do that with. And you can use it or should use it for checking points for graphing. It's faster. Okay, so from this, we have a vertical asymptote at -4. So x equals -4 is our only vertical asymptote. I'm going to skip horizontal for a second and go to holes. So we have a hole at x equals 3 because that factor cancels. So at x equals 3, but we need the y-coordinate. So don't forget the y-coordinate of that. How do you get the y-coordinate of that hole? Into the simplified version. It's so much easier to do it there. So 3 times 3 plus 9 over 3 plus 4 is 36 over 7. Okay, so I want holes written as points. I'm fine if you make that a decimal, but give the coordinates of the point. Okay? Alright, zeros come from the zeros of the numerator. So if we look, do I have a 0 at 3? No, because it was a hole, right? In fact, if we go graph that, 36/7 is roughly 5. So we're going over 3 and up. Let's see, 1, 2, 3, 4, 5. Put a big old hole right there. I want to make sure I can see it, okay? It's okay if it covers up more than just the little teeny point. Make me see the hole. Open circle. Anyway, that is not a 0. You can't tell me there's a 0 at 3 because it's not. Even though that's a factor of the numerator, it gets canceled off. So don't put zeros on holes or asymptotes. So our zeros are just from, if we use this simplified version, it's just from the zeros of these two, which are what? Yeah, at x equals 0 and x equals -9. So you might as well go graph those. Okay. Horizontal asymptote, you want to use the original. It's just easier to see it. So what case is this one? This is case 3, right? Because the numerator has a larger degree. So for that, you're going to need to long divide. Okay, how many times does x squared go into x cubed? That's just x times. So x goes, I need to, by the way, put a 0 here. because it's our last piece that's missing. Anyway, then we get x cubed plus 2x squared plus 1x squared, sorry about that, minus 12x. If you feel like you're going to mess up subtraction, put parentheses around that maybe, somehow make it stand out that you have to watch your signs down here. So we get 6 minus 1, that's 5. We get negative 27 minus negative 12, which is negative 15. Then bring down your 0. Okay, and then the next question, 5x squared divided by x squared is just 5. Multiply 5x squared, and then x times 5 is just 5x. Negative 12 times 5 is negative 60. Do we care about what comes after this? For this problem, do we care what's left? No, because all we care about is that guy right there. Okay? So our horizontal asymptote is y equals x plus 5, which is a diagonal line that we need to be able to graph. Okay, y-intercepts. I would use the simplified version. So these 3 x's just go away and we get 9/4. So the y-intercept, y equals 9/4. It's technically a point, right? 0, 9/4, which is 2 1/4. Domain, just kick out whatever you write on the holes and the vertical asymptotes.
For the y-intercept, what is that x on the numerator?
Oh, it is 0. Duh. Thank you. Yep. Yeah, don't do that. Thanks. Domain, kick out vertical asymptotes and holes. That's an easy way to remember it. So this is all x's. Except what would we have? Negative 4 and 3. Range, kick out anything that's horizontal asymptotes. So in this case, it doesn't have a horizontal asymptote, so it's just all numbers are fine. Okay, so range, kick out horizontal asymptotes. Anyway, then we go to graph this thing. I think let's do it kind of a little bit fast.
Wait, Mr. Atkinson.
Yeah.
The y-intercept is 0, 0 because that's one of the zeros, right?
No,
Or 'cause of, like,
it's because if I
the-
stick a 0 right here, 0 times that is 0.
So the whole thing is 0?
Yeah.
Okay.
So negative 4 for our vertical asymptote. Oh, that was bad.
Fair enough.
How do you graph x plus 5 for your slant? Start at 5. 1, 2, 3, 4, 5. And that point is not on our graph, it's for our asymptotes. Can you go put those back till I say something about them? Go put them back.
Wow, you're sassy today.
What's the slope? It's 1, right? mx, it's just 1. So basically just go through these diagonals. Something like that. Okay, notice, here's our options. This thing could go down here and here, or in here and in here. Those are the typical versions when you have a slant asymptote. Okay, it gets tucked between the slant and the vertical asymptote, or it just dodges them on the sides like that. Well, I think we probably have an idea, just based on these points, which of these it is, don't we? I want you to not graph your line through the hole. That would defeat the point of having a hole there. Okay? So come up to the hole and then continue after it, but don't go through it. How about over here? It's probably going to come something like that, right? Since it has to go through that x-intercept. Good? Start up here. I don't want to scroll, but start with simplifying or factoring and then simplifying. And you can do a lot of things with the simplified version. In fact, I could add also check x-intercepts there as well. All right, this kind, factor everything in the denominators. This doesn't factor in the numerator anyway, but factor denominators first. So this is y plus 4 and y minus 3 for this one. And then y plus 4 times y plus 2. And that one's already factored. I think it's sometimes helpful to see the pieces though with parentheses around them. Okay, so factor the denominators. Now we have to give each fraction what they need in the denominator that the others have that it doesn't. Hopefully that was clear. Like this one has a 4, that one has a 4, and that one has a 4. So we're good on 4s. Y plus 4s, right? This one has a y minus 3. Those two don't. So they need one. This one has a y plus 2. These two don't. So they need one. So if you want to, remember we made a list of unique factors, which was y plus 4, y plus 3, and 2. Y plus 2. So just make sure each fraction has all three things is really what it comes down to. Or maybe it's just one thing or two. Not all three. Not always three. And the other big idea is make sure you give both top and bottom what it needs. What am I going to have to give this last one? Both, yeah. Okay, and then this one needs just 3. Okay, and then you have to go multiply and write it out.
You're forgetting 1 minus 3.
Oh, I wrote it wrong. Should have stepped back further to see it. Okay, and this one needed what? No, we're good, never mind. Okay, so now we, hi, are you listening? Now we multiply, multiply, multiply. Okay, so we get 3y plus 6 from this first group, 2y minus 6 from that middle group. This, we have a little bit extra work to do because it's y squared, 2y minus 3y is negative y. So I'll just write it first. Y squared minus y minus 6. Good on where those came from. That whole thing is over our denominator, our common denominator. Do not re-multiply these. Just leave them like that. Do you have a question?
No.
Okay, be careful because I didn't put these signs in here. So this says minus. As soon as you write a minus, put parentheses around something. Because it's minus this whole business right here. Okay, then plus. Plus, you don't need a, don't worry about the parentheses if you don't want to put them in. Okay? Now, do your best to clean that whole numerator up. The denominator will just tag along. For example, 3y minus 2y, that's just y. 6 plus 6 is 12. So right now I have y plus 12. Let's go deal with that side. Plus 7y squared minus 7y minus 42. Denominator's the same. Just leave it. What else can we do here? Well, y minus 7y is negative 6y. So I'll just start writing negative 6y. 12 minus 42 is negative 30. And then we have this 7y squared. On your test, I guess I'm okay if you do this, kind of like I'm doing, until you get ready to use the denominator. If that would help. Just don't forget to come back and use it again. Anyway, at that point you would factor this, or try to, factor and see if you can cancel with any of these denominator factors. So that one is a little nasty because it's factors, like if you star that, factors of negative 210 that add up to negative 6. Which would take a little while, so I don't want to do that now, but we're basically to the end. Does that help?
Yeah.
Awesome.